All right. So indeed, that's my aim, is to talk about working with robots and humans to make better humans and robots. So for those of you who don't know me, I am originally a mechanical engineer, also from Bristol. I did my PhD in at the Bristol Robotics Lab, finished this summer. And while I was there, I helped to set up the HRI research group, which is now called ECHOS. So I recommend you follow them on Twitter if you don't already, because they're a fun group. Right now, I am a digital futures postdoc here, working with Yolanda Leet and Donald Macmillan from Stockholm University. And I'm leading 2 projects around designing with children for children and around feminist social robotics, which I hope to talk about a little bit later. But in general, I'm interested in human-robot interaction, human-in-the-loop machine learning, participatory design, robots in society, like anything to do with robots and people I'm probably interested in. So, oh yeah, and as most people that I work with know already, I'm desperately trying to find reasons to stay in Sweden. But if nothing changes, then I will return to the UK next year to join Harriet Watt as an assistant professor of computer science. All right, so today's talk, I want to talk about what socially assistive robots are first, then go through a little bit about what I did in my PhD. So talking about actually putting a robot in the real world and covering some of these ideas about working with robots and working with people and how to do that in a way that's better for both. And then hopefully, if there's time, talk a little bit about something I'm doing now at KTH and a different take on this idea of working with robots and humans to further look at kind of putting robots in the real world and doing something fun. So I guess there are 2 key things that I hope to convince you about with this talk. The first is that working with robots and humans to make better humans and robots is really what it means to be working in human-robot interaction now, and to be creating effective and meaningful human-robot interactions. So this is about, you know, building robots that have a direct positive or desirable impact on the user, but then also more broadly understanding the impact of these robots on their social environment and ultimately their potential for impact on society at large. And then secondly, the other thing that I want to convince you about is that to pursue responsible robotics, to engage with responsible innovation and follow kind of ethical procedures, is to pursue effective robotics. I am an engineer by background, and so when I talk about responsible robotics, this is about being practical. It's not just about having some philosophical stance. I kind of want to show you that I think responsible innovation isn't just a tick box exercise, but actually leads to better technical systems that are acceptable and therefore actually going to be useful in the real world. Okay, so socially assistive robots. So some definition might be that socially assistive robots are those which are focused on assisting people through social interaction, and that they are in contrast with physically assistive robots, or those social robots that are just there to entertain us. So these kind of interactive kids' toys that we might see. And typical applications in a one-to-one setting could be guiding and motivating users through tasks, and that's the one that I'm going to focus on. You can also see them in one-to-many interactions. So that could be robots that are trying to influence on group dynamics. And typical application areas would be education, healthcare, fitness, and well-being. So for example, guiding and encouraging children's educational activities, facilitating group interactions in care homes, or the one that I'm going to talk about today, which is motivating people to work out and guiding exercise sessions. So this is what they might be used for. But for those of you who've ever had a kind of underwhelming gym class, or perhaps a meeting with your supervisor that has just kind of left you feeling a bit underwhelmed or demotivated, providing effective social assistance isn't easy, which is obviously why it's something that we value in people like fitness instructors, therapists, teachers, and people like that. So if we take this kind of example of fitness instruction, if we look at what goes on in a fitness session, well, you know, human experts know how to be informative and serious. And this is kind of, this picture is what you might expect exercise instruction to look like, right? With kind of giving some information and being quite serious. But they also know when and how to be much more fun and how to build a kind of rapport with the client that is going to keep that person engaged. So when we think about socially assisted robots, an obvious question then is, well, how could or should a robot fit into this picture and deliver this kind of quite complex social intelligence? And that question really drove the ultimate goal of my PhD, which was to try and get meaningful real-world deployment of a fully autonomous, and this is important, a fully autonomous socially assistive robot that could fit in a setting like this. And in setting up that work, I kind of set myself some ground rules, which kind of reflect my overall research philosophy. So I really wanted to demonstrate this idea that responsible robotics is the same thing as effective robotics, and that to be responsible leads us to effective robots. So I wanted to look at ways of leveraging human domain expertise, because it's a responsible thing to do, but also because it's obvious, because these people are experts at it. I was very keen that this was about augmenting human-human interaction. So this interaction between the instructor and the client is obviously super meaningful, and there is no reason for us to try and replace this completely with robotics. And I wanted to take a mutual shaping approach. So for those of you not familiar with this concept, mutual shaping, there's kind of two strands to it. So mutual shaping kind of says, or to take a mutual shaping approach, says that, okay, I recognize that on robot deployment in the real world, there is a two-way interaction between the robot and its broader social environment. The impact of the robot is not simply directly equal to its technological capability. It's about the emergent interactions between the robot and its environment. And then during robot design, it's about recognizing this dynamic interaction between robots and society all the way through the design and development process. And this is kind of something that I really wanted to do in design of this robot. So into the first study from my PhD, rehabilitative therapy is a demonstrated application of robots. So therapists are therefore the domain experts at doing this kind of interactions, and they would be one end user for any such robot, right? Because they might be the ones who are going to prescribe the robot and work alongside it. So working from them seems sensible and is responsible, as I've said before, but very previous few works seem to actually detail what they thought. So I came up with a focus group and interview study that combined elements of participatory and co-design to actually ask these questions. You know, what do therapists think about social robots therapy? How do they improve engagement? And how do they personalize or tailor their behavior towards patients? Because it became clear quite quickly that that's something that they do. So I came up with this focus group structure, and I just want to highlight how this uses this mutual shaping approach, because it turned out to be really good for me. So in the focus groups, there was a big focus on me learning from the participants. So asking them, like, what do you think about robots? How do you do therapy now? And the idea is to capture what they thought before we bias them, or before I bias them. Then it kind of flipped, and I took the chance to kind of show them the robot and talk about what I thought it could do, and kind of like show them, you know, demystify a little bit what robotics is about. And then you can obviously revisit kind of the initial discussions, and now you have the benefit that you're on a level playing field. So each one of these focus groups was like an hour and a half, and we were able to generate some really great data. By taking this broad approach, we were able to get new ideas for applications, things we hadn't really considered. We were able to identify things about what might happen when we put the robot in the real world that we just wouldn't necessarily have come up with before. And what's super interesting is that what this kind of figure shows is that we gave the participants of the focus groups a acceptance questionnaire before and after. And we showed that just by taking part in the focus group, participants' acceptance of robots massively increased, you know, likely because I took the time to explain to them what I had in mind, and also took the time to listen to them. So I think this is a really nice, already quite a nice bit of evidence or a pitch for why these kind of responsible approaches can lead to better robots, but are also beneficial in their own regard. Okay, so did the study with therapists, great. And then from there, I got interested in the idea of designing persuasive robots. And that was because as I read more about motivation and persuasion, you can call it which one you wish, I came across a particular model of persuasion that really well seemed to match what the therapists had told me about the way that they interact with people. So specifically, the elaboration likelihood model of persuasion basically says that if I'm trying to convince you about something, there's two ways that you might process that message. if you are what they call high elaboration, which means that you understand what I'm saying, you're invested in it, you really want to rationalize and critique what I'm saying, then you're going to assess the message that I'm presenting. Hopefully today, most of you fall into that category. If, on the contrary, you're low elaboration, which means you don't really care about what I'm talking about, it's not something you're invested in, or maybe it's too difficult for you to comprehend, then actually you're going to make a snap decision about me as the communicator, and whether you do what I say or not will depend on what you think of me. Seems likely that most social assistant scenarios fit into this category, right? The reason that we employ a therapist or a fitness instructor to teach us is because we're not really engaging with the rationale, and we just need someone who is credible and likable to kind of get us there. And so luckily for me, this model of persuasion identifies ways that you can make yourself more persuasive. So I guess if you take nothing else from this talk, you'll all be master manipulators by the time that I'm done. So the first one is expertise. So you can, flash a bit of knowledge and try and show that you're worth listening to because you know what you're talking about. The next is similarity. So trying to show some similarity with the person that you're trying to persuade. And the third is goodwill. So this is about trying to show an effective interest in the person that you're talking to. And I came up with a study where I would compare all of these three strategies against a control, where the robot still spoke to you, but didn't really kind of show any of these things. It just talked about the weather or other kind of small talk. And we came up with a study where we had Pepper in the lab acting as a physiotherapy coach, and participants were asked to do an open-ended wrist turn exercise. So they were literally asked to turn their wrist, I don't know if you can see, but like this, and to do that for as long as they wanted. And so the idea with this, or the nice thing about this then, was the number of repetitions they chose to do would be roughly an objective measure of how good the robot was at motivating them to keep going. So in all cases, the robot kind of introduced the scenario, went through this conditioned dialogue, the goodwill, the similarity, the expertise, gave the instructions, and then said, I want you to do the best that you can. And what we found is that the goodwill and similarity conditions, participants did a whole ton more exercise. It really seemed to work. They didn't think it did in terms of the measures, but it did objectively. You can see how many repetitions more they did. And so I was like, great, the robot, we've kind of shown that the robot can use human-inspired persuasion strategies to get people to exercise. Perfect. And I was pitching this back to my supervisors, and one of them kind of raised this ethical concern. And she said, I think this is deceptive. We're actually having the robot suggest that it's got emotions or intelligence, things that it just doesn't. And we're actively using that to influence the user. And she pointed me towards what was then a very recently published standard on the ethical design of robots, a British standard. Now, as an engineer by background, I'm generally all for standards. They are supposed to make our job easier and kind of give us some guidance about making sure we're all doing good work. But when I kind of opened this one up and I saw how basically what it suggests is that we shouldn't be using anthropomorphism, that we shouldn't be designing robots that emulate human-like behaviors because it's potentially deceptive. Well, it kind of was like, well, this is a bit awkward. The whole field of social robotics is really about trying to do exactly that. We are trying to build robots that are compelling social agents, very much using anthropomorphic behaviors that suggest the robot is alive or capable of feeling. And it's not really controversial at all in the human-robot interaction literature to do that. So I decided, given that I've been plugging for responsible robotics since the beginning, I couldn't really ignore it. So I set out to actually do one of these ethical risk assessments for my physio robot. So I conducted the kind of ethical risk assessment, identified the hazards, and don't need to worry about this too much. But the point was I identified what the hazards were according to this standard. And then I tried to think about some mitigation strategies. And I wanted to investigate, well, okay, how big is this risk? Is it really a thing? And secondly, if we mitigate that risk, what's the impact going to be on the effectiveness of our robot? So that original study that I talked about with the wrist turns, I actually included some deception questions on there, and we did an interview follow-up with, did people find it deceptive? Did they find it acceptable? And I did a follow-up study where it was a video-based study where I actually did the mitigation strategies on the robot, turned down the ethical risk, as it were, and looked at what impact that might have on the robot's credibility. So what we found is that generally the ethical risk is quite low. The behaviours were generally found by most people to be non-deceptive or potentially deceptive, but acceptable. And actually, that risk is maybe justified. When we did the study where we did turn down the ethical risk, it was the higher risk robot that got the best scores in terms of credibility, and it was the higher risk robot that was most preferred. But another good thing about this study, or something that was kind of became very clear in the findings, was this importance of mutual shaping, where I mentioned earlier this two-way shaping, because a lot of this acceptance and this idea that this was kind of ethically acceptable was very much linked to the fact that participants were not just thinking of the robot in isolation, but they were thinking about the entire design process that had brought the robot into being. So in this case, this participant was talking about this social interaction that the robot was engaging in. And it's very complicated what they're getting at, which is that, yes, it was genuine, but that's because someone programmed it to be genuine, but that's okay because whoever did that wanted the person exercising to feel comfortable. And it was about the care and the intention that had gone into the robot. And similarly, another participant was like, yeah, but I mean, I trust where the robots come from, right? A human physio has said that this is okay, or it's come from the NHS or from the university. And so it's been authenticated. And so again, it just kind of is a really nice pitch for this idea of mutual shaping, that we shouldn't be looking at our robots in isolation because the users won't really think about them in isolation either. Okay, so what does all of this mean for socially assistive robotics? We've talked about persuasion, we've talked about ethics. So if we go back to our original use case, this idea of putting the robot in this picture, we now have an idea of what's going on with these different behaviors and why they're important. We kind of have an idea that such behaviors are probably going to work on a robot. These social behaviors of having a laugh, having a joke, they seem to work on the robot as well. And actually, they seem to be generally ethically acceptable for doing that. And finally, from the study with therapists, we identified, these behaviors are hugely intuitive in the moment, and they probably need to be tailored to each user, right? We saw that both from the persuasion model, this idea that you need to kind of tailor whether you're high elaboration or low elaboration, but also the therapists were very clear that the approach they take with person 1 is quite different to what they do with person 2. But the question from a roboticist's point of view then is like, how on earth would we then start to think about automating very complex, tacit, intangible social intelligence like this? And that brings me on to the kind of third and final big piece of work of my PhD, which really represented the culmination of all my efforts so far. And that was looking at expert in the loop interactive machine learning for participatory design and automation, which is a huge title, but let's just explain what it means. So the idea with this expert in the loop machine learning, I'm going to see if I can get the pen thing on. Yeah, okay. So the idea with expert in the loop learning is that you have an expert, in our case a fitness instructor, who is watching the participants interact with the robot. Based on what he sees, he can tell the robot what to do. Every time he does that, the robot captures some input data. And by combining his control with the input data, you basically have a labeled data piece that you can learn from. And then you can create a database of examples to learn from. The point, or I guess what's novel or interesting about this, is that it's done in real time. So the robot is in real time interacting with the participants, doing what it's supposed to do. And over time, it can start making suggestions to the fitness instructor based on what it's learning or what it has seen so far. He can say yes or no to give feedback. And then you basically increase how much data you're collecting and how much learning data you've got. So you have this kind of really nice triadic interaction between the instructor, the robot, and the participants. Okay. So the process for doing this then is maybe I put this back up. You co-design the actions and the input space of the robot. You talk to your expert and say, okay, what are the things the robot should be able to do? And what are the things that the robot should be looking at in order to figure out what to do? Then we actually co-designed a teaching interface, and you'll see a picture of that in a minute, that the instructor can use to control and supervise the robot. And then you actually put it in the real world and have him teach that robot whilst it's in action. So we kick off with 12 hours of actually preparing the system. So that's looking at, on a high level, working with Don. So Don was our fitness instructor. You can see him in the photos. Working with him to really understand what's the role of the robot. Is he designing a mini-me of himself? Is he designing a robot that is its own person or its own agent? What does the room look like? Where does the robot go? Where does the participant go? Things like this. Then at a much lower level, okay, what are the actions that the robot is going to do? What's the input space it should be considering, and designing this actual teaching interface such that he could intuitively control the robot in real time. So for us, this is kind of what it ended up looking like. And our input space that we designed with Don covered all the typical things you might expect. So task state, whether they're walking or running, performance, so how fast they are walking or running, their effort, so we've got like the heart rate and the facial expression. But specifically by working with Don and trying to understand, how he approaches training, we also tried to capture an idea of the participants' overall motivation and their personality, which is exactly what he would do if he was training a new client. So we had some less conventional measures in there as well, you can say. And then through the interactive machine learning element, the fact that Don was basically able to tell the robot what to do in real time, he was now able to actively participate in the robot's automation in a way that was just so much more intuitive and meaningful than simply writing some heuristics based on his best practice, right? And we also tried that, and we used it as a control condition in this study. So during these design process, we also asked Don, can you give us the best heuristics that we could have for using this robot? And you'll see that it didn't turn out quite so well. But actually, Don wrote all of this dialogue. So the cheesy jokes like, you can call me Terminator because I'm going to make you run for your life, I'm not taking credit for those. Those are 100% him. And it was very much in line with what he decided about, the robot. It's going to be its own person, and it's not going to be just a replication of what I would do, because the robot is not me. And I found that a really interesting observation. And you can see on this picture the interface. So this was the interface he was using to trigger the robot's actions, to actually respond to its suggestions. So in those two images, the robot is actually making suggestions about what it should do, and he's able to say yes, no, cancel, or whatever. Okay, so the other really kind of interesting thing about this approach, this idea of putting the robot in the real world, training it over time whilst it's being used, it allows us to witness mutual shaping effects. So you remember I said the idea of mutual shaping is you put the robot in the real world and you recognize that it's going to be influenced by its social context, and you're going to see emergent behaviors. So the first element of mutual shaping that we were able to unlock by taking this approach was personalization. So obviously, as Don watched over time the way that each participant interacted with the robot, he saw more of what worked for each person, and ultimately that got reflected in what he taught the robot to do. So much so that at the end of the study, about half of the participants actively commented on the fact that the robot seemed to get better at figuring out what they needed in order to be encouraged. And so, that's because Don had seen that happen and had taught the robot accordingly. And we have some nice data to back up that the robot acted differently when it was autonomous for all of the participants. And then the other thing that we were able to observe, which was really how Don interacted with the robot, like as a kind of colleague or as a workmate. And something that was so exciting to see was that, towards the end of the study, the time in between participants got a bit less, right, because the sessions got longer. And so Don was trying to do some post-run stretches with participants because he felt that, it was getting a bit intense now. People were running for 40 minutes. But then the next participant would arrive. And so he got into a really good habit of getting the next person in, letting the robot warm them up while he finished the stretches with the previous participant. And that is just a great example of kind of mutual shaping, of a way that the robot and the instructor were able to kind of shape each other's behavior and be used in a positive way. And I'll come back a little bit to that at the end. And of course, okay, maybe it's perhaps a good time to point out, this would all be well and good, but it maybe would be irrelevant if it turned out the machine learning part didn't work. But I'm really glad to say that it did. So I mentioned that we trialed a heuristic system that we also designed with Don. And in this particular figure, you can basically see that we had two versions of the heuristic system, and they just didn't score They didn't get evaluated as positively as the autonomous robot that was trained by Don, because the heuristic one was also autonomous, right? It was just following rules, you know, if the speed gets too low, then challenge them or whatever. And actually our autonomous system got rated very similarly to the supervised one, where Don was still in control and was supposed to be giving, you know, expert behavior. So I would say this shows pretty well that our autonomous behavior was well liked by participants. And again, kind of maybe that is probably, or a key reason that happened is because our machine learning system was able to produce a bigger variety of actions, and it was able to tailor those to the user. So this figure is a bit complicated, but essentially what it's showing is we have two different participants, LB and MR, and those were two participants that Don identified as needing different approaches. They were quite different in their exercise behavior. You can see that the heuristic system essentially worked, kind of produced the same action distribution for both of them. You know, it wasn't personalized, whereas the machine learning autonomous, so the autonomous system that was trained by Don, produced quite different ones. And that this autonomous behavior was quite similar for each participant to the supervised one, right? So basically what I'm saying is that the Don used the robot differently with each of them in the supervised setting. The autonomous robot learned that and was able to replicate it to some extent in a way that the heuristic system completely failed to do. And of course, you might look at this and think, well, those heuristics look crap, right? You only used like a tiny fraction of the action space. The heuristics, we worked hard with Don to try and get the best heuristics we could based on his expertise. And this really is the best we could come up with. So I would argue that we really showed that this was a really good way of getting his knowledge into the system in a way that is simply better than the traditional heuristic approach. Okay, turn that off. Okay, but let's just take a step back. Yes, the technical stuff is kind of impressive, and trust me, like I spent a lot of time building the ROS system that went underneath this, and I can't tell you how relieved I am that it worked. But maybe I think what's most exciting or impressive about this particular study is that surely we demonstrated what real world successful human robot interaction can look like. You know, we installed a real robot in a university gym for 3 months, and we delivered a real NHS exercise program to 10 people, of whom only 1 dropped out. That's already great. Like, to get that kind of engagement for 3 months is super cool. Which about 150 odd were used for training. 30 sessions were run completely autonomously with the robot that we had trained using our interactive machine learning approach. And then we had about 50 odd sessions where the robot was testing out these heuristics. But when I say that, you know, it was successful, the robot was really accepted by the people involved. So from Don's point of view, he really considered the robot to be like a colleague, and we had really detailed interviews with him. You know, was it a tool? Was it a colleague? How did you perceive it? And he talked about, you know, well, actually it allowed me to get more things done. He talked about being able to use it to do the warm up while he did the stretches, and he really perceived it as like a colleague, right? From the participants, they perceived the robot to be a gym buddy. So we have lots of feedback about how Pepper was motivating for them and wanted, you know, was quite good at encouraging them. But what's really nice is it seems to be the combination of Pepper and Don together that really made this effective. And this is a great pitch again for the idea of, you know, human robot teaming, and not trying to replace the human, right? But showing that by the human and robot working together, we can do something good. And a lot of people talked about, yeah, the robot is great for giving me this in the moment motivation, but I really like that Don is in the background somewhere ready to do some stretches when I need to. Or, you know, Don says hello to me when I arrive before I start working with the robot, and that's important. So for me, I was really pleased that we didn't, you know, replace Don, and actually we still did something good. So the robot had a distinct but complementary role compared to what Don was doing. And just to kind of prove that this isn't all just kind of me saying this, these are photos from Don's Instagram from during the study. And I think you can see, like, you know, this was a really good experience for him, and he really got on board with accepting the robot, and it was a really cool thing to see. All right, so to summarize my PhD work, in my thesis, I made the argument that socially assistive robots work through social influence. So what I mean by that is that the way that they achieve the assistance, or the way that they do something useful, is they positively change, well, user behavior is positively changed by us using a social robot to intentionally manipulate the social environment. An easier way of saying it is that socially assisted robotics is fundamentally about working with robots to make better humans, right? I think it's fair to say that. On the flip side, I would say that the best socially assisted robotics is achieved by working with humans to make those robots better. And so I hope that in my PhD, that was kind of what I achieved. Okay, so I did say if I had time, which it looks like I do, I would spend the last bit of time talking about some of the work I'm doing now at KTH. So, you know, so far we've been talking about this very safe space of socially assisted robots where, you know, you can probably all get behind the idea of using persuasion and social influence to motivate someone to exercise. But I think maybe there's a slightly darker side of human-robot interaction that is worth talking about. You know, all social robots can affect social influence. The definition of social influence is simply a change in behavior in response to a social environment, and robots definitely change our social environment. So if we're not careful, I think there is a risk that such social influence might not always be for the better. And there was a really fantastic, I mean, it's kind of glum, but it's a fantastic report from UNESCO from last year, and I encourage you all to look at it if you haven't. And this was about, the report is called I'd Blush If I Could, and it's talking about the gender divide in digital skills. And one of the think pieces specifically from that report is concerned with the gendering of AI. And this part of the report identifies that state-of-the-art assistants, so if you think Siri, Alexa, they are obliging, docile, and eager to please, regardless of kind of user tone or hostility. They're quite tolerant of sexual harassment and insults, sometimes actually flirting in response to sexually explicit language. And as much as Apple and Amazon suggest otherwise, you know, these are clearly female agents. They present as female, the adverts showed them as female, the voice is almost unmistakably female. And so these digital assistants run the risk of propagating harmful stereotypes and norms around women being kind of subservient and tolerant of poor treatment. So, you know, given the fact that I've just talked about how much robots can change our social environment, of course, robots also run the risk of propagating these harmful stereotypes. But perhaps if we're a bit more optimistic, maybe they also offer an opportunity to challenge and change them. And so this was what got me kind of interested in the idea of feminist design of social robots. So based on the UNESCO report, the idea with this work is to think about, you know, at least in this initial study that I'm going to tell you about today, can we design a female feminist robot that goes against the typical subservient persona currently seen in digital assistants? And more importantly, can we demonstrate whether having such a robot challenge abuse and gender bias in a way that the current assistants just don't do? Can we demonstrate that doing that improves the robot's credibility and effectiveness and might actually start to influence people's own gender biases and expectations? So we ran, this is super hot off the press. Like, we only finished this study a week or so ago. And we did a first study where we created some videos where we had the fur hat robot here set up to be ostensibly female and kind of talk about robotics research happening at KTH. So the theme of the video was that this robot was talking to young people and trying to convince them that they might want to come to KTH and study robotics. So it talks about, you know, what's going on at KTH and how important robotics is. And then towards the end of the statement, the robot highlights that, you know, less than 30% of humans working with robots at KTH are female. That's our current stats. And it says, girls, I would especially like to work with you. After all, the future is too important to be left to men, which, for those of you who don't know, is a slogan that KTH uses here on campus with their outreach events, and you've probably seen people with the bag walking around campus. So this is a real slogan that the university uses in its outreach. So in the video, the robot says this and then gets abused by the male in the video. Specifically, we did change this a little bit based on the age of the people that were watching the video, but the male actor insults the robot, calling it a fucking idiot or just stupid in the younger kids' case. and implies girls should be in the kitchen. Again, this is for the older kids. For the younger kids, it said something like, what you've just said is really stupid, like you're really stupid. And then we varied how the robot might respond. So we had a control condition where the robot says, I won't respond to that. And that's actually what Siri says right now, if you tell it that it's stupid or a fucking idiot. We had an argumentative response where the robot tried to justify why that's not the case. So, actually gender balanced teams make better robots. And we had an aggressive condition where the robot was like, no, actually you're the idiot and I wouldn't want to work with you anyway. And we ran this study with just over 300 students from a Swedish high school, and each of the students was randomly assigned to one of the 3 video conditions. We asked pre and post hoc questions that were designed to capture any shift in participants' own gender biases regarding girls and computer science, the participants' interest in learning more about robotics, and their perception that they might enjoy working with robots in the future. And we also asked post hoc questions, about the robot's credibility and asking them what they thought, how good would the robot be at encouraging young people like them into working in robotics or coming to KTH. So some of the results, gender differences still exist, even in this country of Sweden. You're probably not that surprised. So we saw the classic results to begin with, that boys were more interested in learning about robots than girls. Boys seemed to think that they would enjoy working with robots more than the girls did. On the gender stuff, so boys agreed more with the idea that girls find it harder to understand computer science than boys do. They perhaps have some of this gender bias. And this bias was stronger in the older kids compared to the younger kids. So we split our kids by those that were like 13 to 15 and those that were 10 to 12. And this kind of bias was stronger in the older ones. So clearly there is work to be done with kids at that age. Thinking about our manipulations then, feminist robots might help. We got a little bit of good stuff. So girls in the aggressive condition agreed more with the idea of it being important to encourage girls to study computer science after seeing our video. And boys in the argumentative condition, they agreed less with the idea that girls find it harder to study computer science than boys do. So there was some shift on the measures that we might like to see. Perhaps the most important result is that when we looked at the credibility of the robot, for girls, the argumentative robot had much more credibility than any of the others. So the argumentative robot was better than the aggressive robot, was better than the control. So girls listen more to a robot that actually seems to fight back when people say stupid stuff to it. And that's great. I would have liked it if the boys had also demonstrated that effect, but at least for now we showed that, we can maybe improve how robots are perceived to girls by doing that. But we didn't get it completely right? I mean, this was a first study, and unfortunately, all of the participants' instantaneous interest in learning about robotics seemed to decrease. Probably because they'd just watched a fairly boring video and they probably did not want to learn more about robotics right in that moment. And whilst girls perceived the robot to be better at outreach than the boys did, I can't stress enough, this study or this work is about making the robot a better communicator to everyone. We want to target the boys, the girls, we want to target people that are non-binary. We didn't get this completely right. One might argue it's almost like maybe I should have worked with some other humans to make a better robot in the first place, right? I mean, this is what I've been saying from the beginning. And actually in this work, this will be the next thing that we do, will be to do some participatory design workshops with young people to try and craft other robot responses. But at least for now, we produced some good initial evidence, or at least I think so, and I hope so, that we've produced some good initial evidence for challenging the status quo around gender norms in human-robot interaction and human-computer interaction when we're thinking about Alexa and Siri and all the rest of it. All right, so I will wrap up. So in this talk, I really hope that I have showcased for you, the role that robots can play in positively shaping human behavior and how to do that ethically. I hope I've shown that working with human experts during robot design and development is definitely the best way to tackle technical challenges, whilst also allowing for this really important and valuable mutual shaping emergence. And that thinking about responsible innovation and ethics is really practical as well as philosophical if we're going to build systems that work in the real world. So in short, I hope to have demonstrated that effective and meaningful human-robot interaction can be achieved by working with robots to make better humans and working with humans to make better robots. Thank you very much.